Recording in progress.
Okay, hello everyone. Something slightly different today. I am going to try and do some archaeology. Well, virtual digital archaeology. It'll soon be the 20th anniversary of my big book, New Kind of Science. And I was going to go look at some of the files that have been stored up for often 30 years or more, um, that that I used in the creation of the book. And I'm just wondering about all those things that I discovered and then decided that they would be notes to the notes and never put in the book. And now they've been lost for 30 years. And this is our moment to find them again. Um, so this is the book. And let's take a look at the original file system. This was kind of archived. You see the dates here. Now, I'm afraid I don't think I can make this larger unless somebody can tell me how to make uh, a finder window larger. I'm not sure I know how to do that. So if it's one of those, yes, there's got to be a way to do
Oh
this.
yeah, I think under view, show view options. And then you can make the font size bigger there.
Oh, look at that. Okay, it just has to be made unbigger later.
Okay, I can note that.
Okay, here we go. Let's hope it isn't specific to that folder. Okay, so let's take a look here. This is all files. This is from that's from 2012. That's pretty recent. This one here is from 2004. This one here, Boolean functions, is from 1999. And I'm surprised there aren't even older ones. But let's take a look at book layout. This is kind of okay. So this is from 2001, 1998. Those kinds of times. I wonder whether this, oh, there we go. It does that if I make it wider. So a lot from 2001, 1999. This is in book layout. This is where I think book layout notebooks is the notebooks from each chapter. So for example, if we go to chapter 5, this is all laid out here, and we go to section 4, for example. Okay, so this is a notebook which has been sitting there since, well, August 8th, 2001 in that particular case. And I guess these are particular graphics that were generated for the book. And here's the graphic. And the way the book was built, those graphics were stored as EPS files, encapsulated PostScript files, and inserted into the FrameMaker framework that was used for actually laying out the book pages. In modern times, that would have been notebooks. But when I started the book in 1991, these were not capabilities that notebooks had. Now, oh, look, there's a thing called detritus here. Okay, so this must have been pieces of code that were not used for this particular section of the book. But so for every page of the book, there's the code that was used. Now we've been going through modernizing some of this, and let's see if we've got. Do we have chapter? No, we don't seem to have chapter. This chapter, or we can look at chapter 3 here. Oh, we don't seem to have anything there either. Well, maybe we can just look at pages. Let's pick a page. Let's look at page 64. Wow. Really? This is, oh, wait a minute. I just clicked on page 64 here. Oh, there we go. That's a different thing. Okay. Here we go. This is more like it. So this is the modernized version of how to make, oh, that's wrong. That's wrong. That's the wrong font there. That's not right.
Note that.
Please. Wow, it's totally wrong. It should be text. And that's the kind of thing we don't want to go backwards on. Okay, so these are all rather straightforward cases. I wonder if I go further later in the book, will I find some non-trivial cases here? Okay, that's again rather trivial. That's another cellular automaton where I don't know why it's quite so complicated to make this, but that's a pretty straightforward picture to make. Let's go further on. Let's see whether we can find something more difficult. Okay, what's this? So that looks like a slightly more elaborate picture. But so these are just modernized versions of the original code that was in the NKS book. This is looking, that was super boring, super trivial. Let's see. We go further on here. Boy, that's really odd because page 660 really has that on it. Let's take a look. 660. Oh, it's not wrong. There it is. Oh, good stuff. All right, well, let's see. 660A. Let's see what that is. That's that. Oh, well, what's missing here is the hard part, which is this piece here, which we can go look at. That was chapter 11, section 5. We can go look at the original here, chapter 11, section 5. And let's see, that's probably this one here. There it is. And there's a whole bunch of code there, but what do you know? There's the actual picture from the book, and there's the code. Now, if we were really ambitious, we would actually try and run this code. I have a feeling that it uses some definitions that were specific to the way the layout was done in the book, but maybe not. I don't know. Let's try. We could try this, and let's see. Let's pick this up and just see whether it still runs. This is now code from very ancient code here. Okay, let's give it a try. So, let's make it a little bigger here. All right, there are a couple of definitions there. Beginnings of new version. SST to, wow, what's that? I wonder if the beginnings of the new version were very old. Let's take a look. So we should be able to see in the original file, wherever we had that original file there. Oh, no. In that original file, that was a section 5, was that right?
Yeah.
Yes. Okay, so here, if we are lucky, if I go to cell notebook history, so this file was created before we were storing notebook history. So that means it was created by the mid 1990s at least. All right, let's see if we can run some of this. Okay, so we got that. We got this. I wonder whether, well, we can just live dangerously and just try running the whole thing. Oh, I bet there's some stuff here. Rectangle's edge, I bet, has not been defined. Let's just see. See, this is where things get kind of difficult because we have to see whether if we run this again, whether we'll get something like the same answer. It's running. What will it do here? I have no idea whether it's. I mean, this hasn't been run in a really long time, so we have no idea. Wow, that's pretty weird.
Yeah, this is the process we have Enrique going through.
Yeah, well, maybe what's happened here is that we don't have something defined, and so it's creating some absolutely giant structure. Let's try aborting that. Wow. Okay. I wonder what happens if we say just 5 lines there or something. And we get down to this. Again, I mean, I just picked this code up untouched for 30 years. And let's see what happens. Replace is not a dispatch table. So, okay, so there's some definition that's missing here. So we're not going to be able to run that as such. Now, okay, so let's go back here. And I'm really more interested in looking not at things that wound up in the book, but at things that didn't wind up in the book. because I think those are the places where we're going to find the more interesting stuff. So this is the notebooks for system IDs. What is that? Oh, that might be interesting. Oh. Huh. I wonder what that is. That's something probably about assigning ID numbers to the, what is this? Complex examples from 1999. Huh. The following was in chapter 3, section 11. It made up of a picture of examples of complex behavior found in each of the various kinds of systems. The picture was subsequently removed from the book. Okay. And by the way, notice that this, we can kind of tell that this is from a long time ago, because look at how small this notebook is. That was kind of, for computer systems of the time, that was the kind of size of screen. So I don't know quite what that was. That appears to have been an image that was removed, never to be used again. And what is this? That's a summary. That might be a kind of a pictorial summary of the main points of the book. Let's take a look here. Okay, let's look at images. What's that? What is this? Wow, what is this? Huh. Okay. Okay, let's take a look at this. Pigmentation. Whoops. Let's see what these are. Oh, come now, let's make those bigger. Aha. Oh, so these actually wound up in the book, or many of them did. The cuttlefish wound up in the book. The book is black and white, so the flatworm ended up in the book, and so on. Now there's a key there. Let's take a look. Let's see what that key has. The key is let's see what the key says. Okay, so we are now let's dive in here. Let's go. Did I just close the file that was archaeology? Let's take a look. It's the finder. That's not what I want. No, here we go. So let's just drag that key file in here and see what it is. Okay. Oh, that's source material for these pictures, I guess. Okay. Let's see. I don't know what some of these are. Daisy petal cell. Okay, some of these are probably unused. Fracture. I think I took a bunch of pictures. Oh, wow. While I was working on the book in 1994, I managed to break my ankle. And that fracture picture is, I'm pretty sure, an X-ray of my broken bone from that time. That didn't eventually make it in the book. Amusing though it might have been to put it in there, that was not in the book. Crinkled paper, I'm sure that was a picture I took. Again, didn't make it in the book. There was a section in the book about fracture patterns, and I was kind of interested in the origins of randomness in fracture. That I think ultimately is another story of intrinsic randomness generation, but I wanted to kind of illustrate that. And actually, I know a place I should take that crinkled paper picture. I'm just thinking of something here. I'm going to remind myself of that. Hold on 1 second here. There we go. I'll remind myself to do something with that later. I think these were pictures that I got. They were electron microscope pictures of silicon, which a friend of mine who was then at UCSD took for me, because I was interested in, if you have a perfect silicon crystal and you just snap it in two, what will the fracture surface look like? And will there be, what kinds of regularities and irregularities will there be in that fracture surface? And this was attempt to do that experiment. Um, and it's kind of interesting. You see, this is very microscopic scale. You see something that could be kind of like, a sand dune or something. Even though this is, well, that's in millimeters, so I don't know. That's 20 kilovolt electron microscope, and I guess that distance there is 0.1 millimeters, so fairly microscopic features. I wonder what this is. Oh, that's an actual microscopic piece of silicon and a very out of focus picture. I wonder why it's so out of focus. Uh, a torn piece of paper. Well, this stuff didn't make it into the book. I ended up not eventually having a collection of pictures of fracture in the book. I had pictures of leaves and all kinds of things like that. I wonder whether there's a let's see whether I have that there. Oh, that's for chapter 8. So if I have images for, oh no, it was in chapter 8. Chapter 8, I wonder where they are. Forms, moth antennas, all kinds of things here. Well, now I want to go look at the actual sections of this because I'm going to show you one more thing about that. Was section 6? There is no section 6 here. See, but you can never tell because sometimes those sections, sometimes I renumbered the sections because the section didn't make it. Okay, so 5 has nothing there. And 7, let's try that. Leaves, there we go. Oh, wow. Why is there a leaves and leaves.zip? When is that file from? 1999. I wonder why all these files are from 1999. Because it must have been that the file system was moved at that time. Because what the heck is this? Oh, those are, okay, so these must be, I had an array of mollusk shells showing the ways that mollusk shells fill out a parameter space. Those were the originals of that. And here we have, oh, look, there's a shells.nb. I wonder what that is. Why this? Okay, that's not very exciting. That's just showing how they got laid out, although it does have information on something about the names of those mollusks, which I'm sure are in the notes at the back of the book now that I think about it. All right, let's take a look. Okay, so that was that was a little bit of the image generation. Let's take a look here at and there must be some interesting images. Let's see, in chapter 2, I'm guessing there are interesting arts images. Let's take a look at these. Yeah, these are images. Some of these images were rather hard to get. Some of them, no, these are not the originals. These ones were quite challenging to photograph in situ. But I think that's not what those are showing. Let's see what some of these are. Graphics archive. What on earth is that? I have no idea what that is. No idea. Let's see what we've got here. Well, that's empty. Let's see. I see what these are. These are probably the actual raw files. Yes, I know what these are. These are the raw files that were used in the that well, actually this is interesting. I wonder whether we've used these for anything. These are these the high res files that we just used for the notes?
No,
I wonder.
they are not. Should they have been?
Yes. Every single graphic in the book is here.
What? That's amazing. Okay.
Somebody had asked me. I knew that was the case. Okay, so they're under graphics archive.
Okay.
So every single graphic. So you don't have to cut them out of the PDF. They're right here. Yeah, they're right here as EPS.
It's tremendously helpful.
The Yeah, these are the EPS files that were included in the FrameMaker files to make the book.
Okay.
Now, graphics. I don't know the graphics. I don't know what the difference between graphics archive and graphics is. That's I
EPS
don't.
versus PDF, I think, right?
No.
Oh,
They're
okay.
all EPS. Maybe graphics is the original thing. I'm not sure. I wonder why that has a weird can't. Postscript conversion warning. Universe condensed light italic not found using Courier. Okay, so I see. So this refers to a font that is not on my system anymore. It was a font that was on the system. See what I'm saying? It was a font that was on the system when these files were
Right.
originally dealt with, but is no longer there.
Yeah.
Although clearly we can find that font again. Um, huh. Okay. Well, that's a useful thing. Okay. I wonder what extras is. Chapter 8, Biology Aborted. The heck is that? I hate to even think what that is. That looked like it was just a raw list of files from 1997. Growth notes. Okay, let's find out what that is. That's my archaeology file. Let's just move growth notes in here. Wow, that seems relevant for something that I was about to do, actually. Let's see. How do I format this more nicely? I think what I want to do here is just to say, flatten this, and then column. I see. Okay. This is just notes about how things grow. I didn't talk much about gastrulation in the book in the end. All right, so that looks like it's not that exciting. Well, it's dropped material. Oh, what on earth is this? I have no clue what this is. Algebraic axioms. Why is that here? See, this is the thing that is kind of outrageous because I've just been working on metamathematics and I don't know what this is from. This looks like a hierarchy of algebraic structures. I don't know why I had that and it wasn't in the end put in the book. Let's see when that's from. That is from May 15th, 2000. Okay, mathematics note -1.text. Huh. Well, okay. That's just some piece of text about mathematics which wasn't included. Okay, what is dictionary? I wonder what that is. That must be spelling words. Oh, you know what? We should open this up because that, I wonder what it will do if I just try and drag it in here. Okay. See what happens if we just render that. Okay. Oh, wow. Well, that's spelling words. That's a useful thing. That's spelling words from the NKS book. Those are things added to the spelling dictionary.
I remember Linda Sherman telling me that I think she was the one who had to gather this list.
Long ago.
Yeah.
Okay, well, there's probably words here for our current spelling. I'm
really?
gonna.
Okay.
I mean, why not? I would think there was.
Yeah. I can track that if you want.
Well, here, let's send this out. Shall I just send this?
Sure. T spelling.
I guess I can send it to the spelling list. Spelling words from the NKS book. And there are a lot of them here. Well, there's some good ones like Ptolemaic and things. I wonder whether we have that in our current spelling dictionary. Well, okay, that's an interesting thing to find. Presumably, these words are somehow in the index. dicots, for example, type of plant. Okay. All right, let's see what is converted. Oh, those are MIF files, maker interchange format files. All right, let's see what's checking. What is all this stuff? 2001 code tests, file dates, people dates. Hey, I wonder what that is about. Let's take a look at one of those. Oh boy. Yes, yes, yes. I remember this. This was horrifying beyond belief. This is for the people in the listed in the index. I wanted to put the dates of all the people and the main countries that they were in. And that's pretty easy for Leonardo da Vinci. I don't know why there are multiple copies of Leonardo, but something like this, that was somebody who's not as well known. And okay, source material, and that's probably a website. I wonder whether it still exists. Oh well, in 25 years, I guess that's what happens to a website. But boy, Nicholas de Bruyne was still alive. Wow. Okay. Anyway, so this was a whole bunch of work necessary to find. I don't know what yellow means. Yellow must mean okay, that's source material for all of this. And okay, that was interesting. So I wonder what happened to this person, whether we managed to find the actual name. Okay, so there we go. That was people dates 4. So I wonder by people date 6, had we found the name of this particular chap? Let's take a look. This was a big adventure trying to find these. And let's see what the let's see for the M's. Oh, look, they more and more have turned green here. Okay, look at that. We found him. Okay. Okay. Faculty listing, date of birth. There we go. Title professor. So we found him. Of course, we probably have everybody's birthday. We only gave the years here. We probably should be. We could make a whole birthday list. Oh, look. I guess we actually emailed the person himself, received new email address from Yuri Matisevich, and sent mail again on that date. So that's probably how we determined the date of birth there. So I wonder why that one is pink. That's a person I actually know personally, so I don't know why it would be. Oh my gosh, that we were actually asking this person, what do you count as? Should you be listed as US or something else? And so we got the actual original statement here. Okay, this is again when you go really. This is what you have to do to actually get these things right. And I'm sure there are ones here that okay, so this is the actual original mail. Is mentioning you in this book, and my task is to collect the background information, your current listing. Okay, and then we actually got the date from here, from the actual person themselves. So yeah, so that's again, that's the and actually we should collect these files because there probably is additional information in these files that is interesting that never made it into the actual book.
Okay.
But these files are definitely, if nothing else, they're kind of what on earth is that, for example? I wonder why these things are see now something like this, we probably have updated it. Let's take a look here. Huh. Oh well. I mean, that's one of the unfortunate things. So that person probably died before the book came out in 2002. So it was updated after this was created, but before the book came out. Uh, like some of these, let's look that up. Okay, so that's a person where we added the uh, the death date after the book was out. So, but it appears in the online book. Kind of a grim business, but anyway, interesting. Just another complicated piece to the construction of the book. Let's take a look at some other things, which I want to say about that. Let's take that file out. Okay. Okay, so that was all kinds of checking there. What is archives? Abandoned pieces. Chapter 10, Section 11, multi-level logic. Now I'm curious, what did we abandon there? What the heck is this? Oh, okay, I know what this is. This is looking at looking at how to represent iterations of a cellular automaton as Boolean expressions. And that, yeah, I think that didn't. There's a piece about that in the. Oh, look at this, book IDs. Okay, that is relevant for something Brady knows about here.
Right.
So if,
and I think I already have that.
Okay. All right, let's take a look at what else there is here. Notes code. Okay, that must be all the code from. I don't know why these things keep on opening behind those notebooks in front. Okay, so that's the pure code extracted from the notes. Again, for a computer, a small computer whose screen was much smaller. Okay, outtakes. Oh boy, did I already have that convention of using outtakes back then? I thought that was a more recent convention. Okay, these are still from 2001, 2002. Let's take a look. Pictorial summary of the book. Oh, I wonder whether that was probably going to be a. That's interesting. Oh dear, 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 dear. Okay, what do we do with a quark file? Yeah, well, don't know what we do with a quark file, but it might be interesting to look at. That was probably the analog of what I've been doing in some pieces I've been writing recently, of having kind of a pictorial summary of the document as kind of a initial information. Okay, this is. Oh wow, do we have this? That must be the actual PDF. Do we have this?
I wasn't looking. The new science hyperlink.pdf. Yes, I have that.
Okay. All right, fine. Is that the source file you're using for things?
That is, yeah, that's the source file that I used for providing chapters of the PDF. And I believe that that's the one that has colored images in it.
Okay, I know what this is. And in fact, this is something that I should be aware of for the thing I'm going to write about the publishing story of the NKS book. This is a TIFF file, which was the signature. So this is a printing signature with 8 pages on it. That page there was the one that produced the bug in PostScript that caused the raster image system to fail. So I guess this was a redo of that. Wow, I don't know what this is doing here. This was a redo of that, so we should remember that place.
Okay.
All right, let's see. Going back here, this was the book, the layout for the book. Layout first printing. Oh, I see. That was a frozen version of the layout from the first printing of the book. Text analysis, what's that, I wonder? Text analysis 01 from November 2001. That's the number of times the word "the" occurs in the book, and other such things. Oh, and this is the number of This is the Wolfram language functions that appeared in the book.
Oh, that's fun.
It's fun, although that text is all available in the data repository now. The full text of the book is in the data repository.
Oh, okay.
That's translations, of which there are many fewer than there should be, because we I don't know what all that is. That looks like office piles.txt. How weird. Piles of documents lying around my office include. What on earth is that from? January 5th, 2001. Huh. Well, that's amusing. I mean, that has some, but it says it's from New Science Book Workflow Office Piles.txt. What is that doing there? What a strange thing to have there. Copy editors.txt. What's that? That's people reading different pieces of the book in January and other. Yeah, in the famous. Did anybody, review this book? Well, yes, a lot of people did, with a lot of detail. The let's see, we're printing screw up 01. What is this? That might be. Those seem to be the EPS files. And let's see what was the result of this. 1731 EPS files. So that's the number of kind of illustrations in the book, I suppose. RGB, I don't know what that is. Okay. To-do.txt, always good to look at old to-do files. That's from June 26th, 2000. Let's see what that has in it. Okay, this is interesting. Okay, so let's make that a little larger if I can. I don't know why it's doing that. Okay, this is amusing. So this was during the last, so this was when? This was, what did I say it was? It was June of 2000. So the book was finished in January of 2002. So this was the look at that. Chapter 5, multi-way systems, was still being worked on in 2000 and in 2000 there. Multi-way systems have obviously become a very big story in our physics project. Now they were that's something that was being worked on then. IC asks on our live stream about the folder called translations. The story of the translation of the NKS book has not been a happy one. Quite a few publishing companies wanted to translate it and sent us samples of their translations, and they were awful. And we basically decided it was better to have no translation than a bad translation. And there was one person who, for their own purposes, translated a big chunk of the book into French. And they did a really good job. And in fact, we commissioned them to finish the French translation. And we have a French version of the book, which I don't think has ever been put online, but it should be, because it's a really good translation. And French is about the only language other than English that I can read. And even I can tell that it was a good translation. So we're still, somebody should do a translation into some other languages. It's just a hard book to translate because it was written rather tightly and rather carefully. And it may have gotten easier to translate now because the ideas in it have become a little bit better known. And so it wasn't the case at the beginning. People were like, how should I translate the term, computation or something? And it wasn't clear how that should be translated. But now that these things are a bit more familiar, it may be easier to translate. It may be worth actually exploring that again. But again, and I'd be interested in feedback from people. At the time, 20 years ago, we thought that a bad translation was worse than no translation at all. And We had versions in quite a few languages that people had sent us samples for, and they were surprisingly bad because it is a surprisingly difficult book to translate. It's also difficult because it's a book written in sort of everyday language, but precisely. And it's not something where you can, if you make a sort of technical translation, it will be unreadable to a large chunk of its audience. And if you make a kind of impressionistic translation, it will be wrong for its audience, so to speak. So it's a bit challenging from that point of view. Um, yeah. So, for example, here this is a section that didn't make it. Geological structures never made it into the final book. Okay, chapter 9, which is about fundamental physics, says much to finish in June of 2000. Of course, that had to wait another 20 years to actually get really finished. Okay, so this is lots of details here about. Okay. Oh, combinator search for plus. Wow, nothing ever changes. That we finally, I finally did that for these things that I wrote about combinators. And I think I found one version of the combinator for plus back in the 1990s, but finally really did that as a serious project in late 2020 in connection with the 100th anniversary of combinators. But it is encouraging that not too much in the to-do list here was undone. Let's just see here. There are later to-do lists. Let's look at the to-do list from November 2015. Okay, so that was encouraging. Look at that. That to-do list has much less on it. So only chapter 9, the notes of chapter 9 about vacuum fluctuations in string theory, okay, where it needed just 2 sentences. So this was as the book was really getting finished. I didn't even know I wrote about topological defects in the book. I guess I did. But let's see. Well, if we go on here, I think this is where things are going to get much more interesting. Book research and so on.
I'm just sending you random things. I've sent you a couple emails too, based on some things that you've talked about.
Okay. Oh, topological defects. So that's where that to-do list item ended up.
Yeah, I guess.
Okay. Let's really dive in. I don't know why there's a section called Boolean functions. Let's even see what that is. Oh boy. That is the deep predecessor to Boolean minimize in Wolfram language. It was a big problem in the 80s and 90s. This question of Boolean minimization was something which was like, oh, it's an NP-complete problem to solve satisfiability, or we can't actually minimize Boolean functions. But it gradually got easier and better to do that. And eventually that turned into the Boolean minimize function in Wolfram language. This was a program, I think came out of Berkeley, that was one of the programs that was available in the 1990s for doing this kind of minimization. And that's what I used, for example, for doing the minimization in chapter 10, where I had a that minimization there, where I'm trying to minimize the Boolean functions that represent applications of a cellular automaton rule. And that was done using this program. But I don't know quite why that made it to a top level folder here. What is material from others? Okay, that may be. Oh yeah, this open problems. This was a thing that I started producing after the book came out, and I got to about chapter 3, and I've been meaning to finish that. And maybe for the 20th anniversary, I should try and finish this. Hey, how about that? Among all the other things that I'm trying to do, let's take a look. I do. Oh, look at this. This is okay. So that file is from 2003, and this is oh, I see. This is they were graded for difficulty, and given their and actually we should these should have been fodder for the summer school. We started the summer school in 2003. Um, and okay, so I got a certain distance through this. Looks like chapter 3. I got a certain distance through this open problems collection, and I have to say, not a lot of people seem to have read this. Oh, I got further than I thought. Okay, I didn't. Oh, look at that. Are dualities in string theory related to the principle of computational equivalence? That was an exercise, so to speak, here. One person who I know did look at these open problems was Jonathan Gorard, the key person on the physics project, who looked at them when he was in, I think, early to mid high school. It was many years after they were written. So if the only thing that happened was that the open problems brought us Jonathan, that was not such a bad deal. But let's see. Okay, so the real meat of this, I suspect, is in book research and in programs. And I wonder I do wonder what's in scrapbook here. Oh my gosh. Okay, I think we have these. This is probably pictures from when the book was being actually printed. Okay, various people involved in printing. I think we're dealing with actual, what is that? That's some picture of, this is what in the end, everything turns into is actual, production manufacturing type stuff. This is probably someplace in Canada. I'm guessing these are not pictures taken by me. Somewhere here, probably. Oh, look at that. That's that's signatures from the okay, so that must be that looks like the controls for a printing press, and that's a piece of the signature of the book coming off. Well, probably maybe that's a test page for the print run, and probably somewhere here, in the end, it turns into a bunch of boxes. I do know that a semi-truck worth of books managed to get misplaced by a certain large book retailer, which caused all kinds of trouble. How you managed to lose literally a whole truck of books that have been marked with all the right barcodes and things is a bit unclear to me. But anyway, well, let's see. So that's that. Oops, did I just close? Oh no, did I just close? I think I just closed that whole thing. Let me open it again. There we go. This is okay. All right, let's take a look at what I think is going to be some of the more interesting sections. This is programs. This is all the programs used. Ooh, that's not good. Well, we're going to have to go through and redo these sizes later. Different folder. Okay. Oh, look, there's like Universe 96. Those were programs to do with the early prehistory of the physics project. Now, actually, for some of these files, the ones related to the physics project, we've actually put these in the working material archives. They go back to 1994 here, and those will be from these folders here. So like here, oh, look at that, programs. There we go, multi-way systems. So that is probably that. There it is. That is what will be from here. So this should be such aptly named program files as universe.nb. And why doesn't that work? So, and some of these things here are programs that were connected through MathLink, now WSTP. These were low-level C programs that at that time we had to have as separate things to be able to run some of these kinds of things okay, so these are from like 1997. Now, if we look here, I'm sure there are things here, I don't know, planar networks. Gosh, I wonder whether we have that functionality. That's 1997 vintage stuff. I wonder whether we have that functionality. Now, I do have a certain urge to go do a scan of this file system and find out the distribution of dates. Let's see. And I think Icy was asking, what's the oldest file on the book folder? Yes, right. File system scan and file date. Exactly so. All right, let's see what we can do here. Let's, when in doubt, use code. Okay, so let's see. Let us go in this whole new science folder. This might take it a while, but it's okay. We'll just let it crunch in the background. Let's go in our archaeology file here. Okay, let's see. Book file dates. So let me go ahead here. I wonder if I just pull that in here, whether it will. No. Oh my gosh, don't do what I think you're going to do. Yeah. No, that was possibly, it was trying to pull in every file from this. Let's see whether this works. There we go. Okay. All right. So let's say we want to do file system scan of file date. Or is it file system map? We probably want to do file system map of file date onto this. Now, I wonder what that will do. Let me see how file system scan map works. On the root, down to level n. So let's just do level 1 here. That's very odd. File date. Subdirectories are represented by an association. That's very odd. Why would that not work? Ah, look at that. Okay. Oh, I see, because it's going to files. It didn't have directories there. Okay, so we've got here. So now what we want to do is we want to not have include directories, file name forms. So we don't want all the directory names. So we want by default all file names. Oh, I see. Okay. So here, isn't there a way to make file system map? Nested output association with R levels. So if I say comma 1 here, there we go. So that's now going to give me all the files. And now if I say date histogram of this. Okay, great. Okay, so it's doing the right thing. So now what I want to do is to get this for all files. And I want to say, let's live dangerously. Let's just do it down to level 3, just to make sure that it's still working. Okay, 945 files. And let's do a date histogram of that. Okay, that's interesting. So that's showing, oh, I see. The majority of files were comparatively new. There were files back here down in 1992-ish. So if we say, if we find what the, let's see, we want to sort by, well, actually, if we just do a sort of percent, well, actually, we could just say take smallest of percent 22, comma 5, for example. And there we've got, there we go. Look, 1992, we've got files here. The computation models, square root of, this was a square root register machine and some, recurrence equation type stuff from 1993. And that was at, okay, so that was recorded. So that was because I was working late at night. Now, in fact, another interesting thing to look at would be the time of day of all these files. That would be another fun thing to look at. But let's try and get the actual distribution of dates of all the files. So let's go ahead and say infinity here. And it'll grind away for a while, I'm sure. And let's just let it go. By the way, we should have a progress monitor for file system map. Be a good thing to add.
Okay.
Okay. All right. So let's go look at book research here. So we've got from 1989, we've got some things here. This is cellular automaton, some files. So 1989 is before I really started working on the book. There should be files from the earlier 1980s of, oh, look, this is connections. Okay, ideas for the, what were these? Oh, look at this. Wow. See, this was before, okay, we have to look at this. We have to look at this. Oh, it's finished here. Wowee. Okay, let's look at the histogram. We'll find out my life and times here. That's not a good sign. That's using absolute times. That's using, why did it do that? Why on earth did it do that? Probably because there's some corrupted dates here. I think we have to tell histogram to use, well, let's say, we just say years here. Oh, whoops, I meant, oh, that's why. Silly me. I should have said date histogram. My mistake. It did exactly the right thing. Okay. Wow. So a lot of, let's just say, if we say date histogram and we bin it by, let's see, bin spec there. We bin that by year, month, day. Let's just see what happens if we bin it by months. Okay, so that must have been right around the completion. There were a lot of files that were rewritten there. So there were 12,000 files that were rewritten there. Actually, to give some sense, let's just find the length of all files. Okay, so the sausage was made with 70,000 files. And I wonder what this was. That was some other. So right there, that was presumably, that was the finishing of the book. And we see here, this was the kind of, I mean, we can look at this on a log scale, I suppose. Let's see what happens if we do that. I have to remember how to do it. Height spec log. And we'll probably see up. Oh, I see. I need to say log of the count. And I think we can get, okay, that's kind of cool. So that's the, okay, so that's basically showing the major periods of time when the book was being worked on. It's interesting that there are these gaps that I think correspond to times that's probably version 3 of Mathematica is 1995. I thought that was 1996. When was version 3? 1996, maybe. Now I do have to try and figure out how do we find the time of day
It
for
was
each of
1996 for what it's worth, September 30th,
Okay.
1996.
So I wonder how we find the time of day for every one of these files. I think we say date value of we say is that what we want? We want I'm just trying to remember how to do this. Or do we say time object of, let's pick up one of these things here. This is going to be interesting. I'm about to find something out about myself, at least. Oh, look at that. That is very encouraging. Okay, we are going to try this. Okay, what we're going to try doing is we're going to say in all files, let's just take a random sample of all files, comma 5 or something. Okay, and then let's say values of that. And then let's map time object onto those. Okay, and let's say 50 of those. And let's now say date histogram of that. Let's just see if that produces a reasonable result. Okay, it does. All right, so what we're going to do now is we're going to try doing that for all the files. And this is going to give the time of day and GMT -4, which I'm a little bit confused by because I was really, was that fast? Well, let's see, length of all times. Yeah, apparently
Usually
so.
it's the front end rendering that takes forever. You know, when you suppress it, things go faster.
Well, let's see. Okay, so that's actually very weird because I would have expected to see something quite different here. I mean, maybe there was a big burst of files that was released at a particular time in a particular year, but this is surprisingly uniform across the hours. And I would have expected to see this mostly at night, so to speak. So I'm really quite confused by that result. I wonder if we actually plotted as a function of date, we could probably plot the date and then the time of day on that date of every file. So I'm just curious to do that. So for each file here, I wonder what happens if we say, I wonder whether this works. If we say, well, here, let's just do, let's say, hash, comma, time object of hash, and let's say random sample, all files, comma, 30. Okay, and let's just now say, okay, let's say values of that. Okay, now let's just see whether this happens to work. List plot of that. That was not encouraging. Let's try saying dateless plot of that. That's odd.
Is it because
Okay,
it's
so
a table?
no, it should work. I mean, this, I think we have to convert this time object into a an hours. Let's see. We want to say hour exact. Yeah, great. And now we just need to say joined arrow false. Okay, so those are those random values. Now this is where, so this is hour exact. So this is time of day from, okay, so now we're going to show the, let's just do this for a few more. Let's do it for 500 of them. Okay, so this is showing the dates, the creation dates of those files. Okay, this is what I would have expected. This is when I was playing CEO, so to speak, I think, he says. Well, let's find out. So let's look at this for all files. This will be 70,000 data points. Let's see what they look like. And then we can probably also look at the density of these files. Okay, wake up, wake up. And we can probably do a kernel density estimator to get the overall density of these things. Wow, I'm surprised this is taking so long. I wonder what it's doing. Well, let's leave it to grind away there. I'm now curious. What's in these early notes? This was from, when was this from? 1989. So this is prehistory of the book. This is before the book started getting worked on. So, and let's see what was, for example, the note about NP completeness. Oh, it doesn't like that. Oh, look at that. Okay, there we go. There is my life in files for a decade or so. Okay, so let's take a look at what was going on here. Wow, there's some weird stuff here. What, I wonder what those stripes are there. Well, that must have been an automated process of some kind that was spewing files out. Because here, okay, this was my sleep time. That sounds about right. And then towards the end, it got crazy. And that was the density, that was the intensity of actually finishing the book. And these are, okay, so that's interesting. There are files back here from 1983 and so on. We'll look at what those were. So that must have been the first burst of kind of activity with the book in late 1989 before I really got started. And then 1991, it should have been, let's see, it should have been, I thought it was June 1991 that I really got started. I did this grand tour of the US and Europe talking about Mathematica version 2. And right after that, got started on the project of doing new kind of science. And what you see here, so there should have been lots of activity in the evening time. So what was happening? Oh yeah, this is 1996. That's when I was trying to get version 2 out, but version 3 out rather. And that's why there was much less density of work on these files at that time. So I assume these are creation dates of the files. And so that's showing us, yeah, well, this is interesting. That's kind of for me at least, it's interesting. So now I'm actually curious, what were some of the earliest files here? So I guess we say, in all files, we say take smallest of all files, comma, let's say 20. Okay. Oh, look at that. Okay. Reversible cellular automata files from 1984. And here's cellular automata from 1980s. Okay, so that's the original code that I had for oh, wait a minute, my local chat system just failed. It's kind of annoying and weird. Okay, so that's um okay, so I had a whole system for running cellular automaton simulations, and I had some stuff that was linked into SMP actually, the predecessor of mathematical morphem language for doing this stuff. But this was just pure C code that I had for doing this, that I guess is listed here under 1980s code. Now I'm curious. Okay, so that's that. So now I'm curious what some of the other things that were in here from these early notes were. How do you open a file in modern times? These were files that were just pure text files that uh, um, um, uh, that how do you open a text file? I thought I could just move it into here. Oh, there we go. What is it doing? How is it doing this? I don't even know how it's well, I wonder if what I do, I wonder if I just say read string of quotes. Oh, look, I can go to a file browser here. Let's see if that works. Let's see, I am in New Science, and this was in book. No, this is in, where is this in? This is in book research. That's right. And this is in book research 1989. And that is under complexity, ideas. Okay, so let's see if we do one of these ideas there. Oh, what's going to happen here if I say this? Oh, wow. Huh. Okay, so that was a pre-history. That was from, what was that from? That was from November 1989. Story of complexity, distinguished from randomness. Okay, so this is some early thoughts about what would become the book. Let me see whether there's some other things into it. Let's see what are small ideas. I wonder what that is. Let's see whether this is maybe a rather silly way to do it, but I think actually I wonder whether there's a different. I'm trying to think, how do I open a file that doesn't have a okay, let's go here. Small ideas. I don't know why it doesn't have that closing double quote. Okay, it's early small ideas. Okay, I wonder what death was about. Who knows? Let's find out what that file was. Wow. Okay. That's probably for humans. I don't know why I had that in there, but let's see. It's probably when I thought that there might be a way to explain things like the Gompertz distribution in a universal way. Let's see what the table of contents looked like back in those days. Um, let's see. Uh, let's see. We'll be writing / contents. Wow, that wasn't a very long version of the contents. Why I am writing this book? Well, okay, from 1989. That was December 25th, 1989. I wonder what was in the preface in those days. Okay. Well, turns out they all were true, so far as I know. That was probably when I had less. Let's see what I was going to say about quantum stuff. Let's see back here. Ideas / quantum. Boring, very boring. Let's see. Okay. Did we look at, there's a to-do list there. To-do lists are always fun. That was under CA, 1989 CA. Let's go and look at this. Am I reading this correctly? CA backup to do. Am I right? Oops, no. 1989 CA. There's the to-do file. Programs to write. Let's see whether we've done all of these. That was from February 11th, 1990. Class recognizers. People ask about those repeatedly. Okay, we've done all of these. Neural net simulator. Neural net learning algorithms. Okay, that was 1990. That was like 22 years before people cared about these things. MP complete problems, statistics of instance space, core wars in Mathematica. Well, maybe nobody's ever heard of core wars anymore. It's kind of an early kind of malware-ish kind of play. Okay, hard sphere gas simulation. We finally got a decent version of that recently, although it's harder than one thinks because of round-off errors. Okay, well, so the good news is I think we've done most of these now. Neural nets, we have a giant system for dealing with that. I'm curious. Okay, so this was from 1989, looking like there was some sort of early book stuff there. Let me just make a note in what I'm doing here that this is all kind of 1989. Well, it actually says there, but 1989. Whoops, not 18. 1989-ish. Okay, so now let's look. Let's go on and look here at 1990. What happened in 1990? Oh wow, what's this? Irvine, California. I don't believe I've been to old research. It's all 1990. What on earth was Ramsey? Let's find out what Ramsey.m was. Wow. That looks like some kind of Ramsey number business. Wow. I wonder what that was from. I wonder what that is. I mean, I wonder whether that's actually still interesting. Hmm. Yeah, that looks like some kind of pattern avoiding sequences. Interesting. And those there, TM files are translation files for going to C code. So some of these things here are .spark will have been for a Spark processor. I wonder what sounds.m were. Why is this opening its files behind? Okay. What the heck is this? What the heck is this? Okay, we can take that and let's go in our archaeology file folder. And I have a great urge to just try playing that. Ouch. Okay, well, that's an echo from the ancient past. It's always like, what's the last one in the sequence? Okay, let's take a look and see what that. This is kind of like, if one could play the things from. Oh, that looks jolly.
Those are so cool.
It's kind of amusing that one can, it's like one day we'll be able to pick up some trace of what was being played in some, cave in 20,000 years ago or something. But this is a little bit closer than that. Ouch! Sorry about that. Okay, that's a little unusual. I don't know why those are there, but December 9th, 1990. So that means that play was already a function in Wolfram language at that time. I wonder what Turing.m is. Oh, wow. Those are famous Turing machines. Huh. Okay, and that's a Turing machine emulator there, written in Wolfram language in 1991. It looks very much like it would today. I can pull that cell in here. I can pull it over here. I can evaluate that. And let's see whether I can just run it. Let's just try running some of these. Just to see whether all this stuff still works. Okay, those have halt states in them. Okay, so now let me see, what do I do here? Show Turing of Turing evolve. Okay, so it's show Turing. Of Turing evolve of, let's say, Ewing 1, comma, let's say, I don't know, 40, comma, 100. I don't really know what I'm doing there. Look at that. Amazing. Back from hibernation. It kind of reminds one of sort of, it's not quite cryonic suspension, but it's something like that. This thing has just been sitting there since February 3rd, 1991, probably untouched since that time. And now we are minus, well, let's see, February 3rd, 1991. Oh, come now, unit convert to years. 31 years ago. Okay. Well, it's pretty cool, I think. And it's pretty satisfying that these things that one created, 31 years ago still just run. And now I'm curious what some of these other ones are here. Logic.m. Oh, wow. This is algebraic versions of logic operations. It's not completely useless. Let's see. Density estimation. Okay, something to do with histograms. Density estimation. Collatz.m, that'll be the 3m plus 1 problem. And why it has a piece of mail stuck in the middle of this, I have no idea. Oh, I see. This was a sped up version that uses some kind of optimization here to do this. I wonder what CA crypt is. That's in C, so it's harder to tell. All right, let me see. Why this was under Irvine, I don't have the slightest idea. Oh, only that was, only those top ones were. Okay, so then we've got, okay, Andrew, who is still working with me today, although in a different role. That was from 1999, fluid mechanics. I have no idea what that was. eProver, that must be an automated theorem proving system. That's July 12th, 2000. That was right around the time I was finding the simplest axiom for Boolean algebra. Andrea, also still working with me today. Oh, wow. Oh, wow. Look at this. This may be some color versions of some images. This will be cool if it is. If it is color versions, I'll be very thrilled. No, it's just regular ones. Okay. There's the animals. That was a big story of trying to get animals which had the right, for example, facial expressions that didn't look too silly. Okay. So various kinds of critters here. Okay, so the cuttlefish was in color originally. Okay, we should and looks like we've got some of these pictures from Corbis. I don't know what some of these were not originally in color. I've always thought it'd be fun to make a color version of the animal pages. And this, I guess, and Brady, this is something to note down. This is where the original color pictures are.
Okay.
Yeah, actually, this is really cool because I've been really wondering whether we could find color versions of those pictures. And this will give us the information to do that. I mean, maybe if we do a web search today, we'd be able to find some of these things just from their black and white versions, but this is certainly more convenient. That is great.
I just wanted to note that I think that one of the links that I sent you has a gallery of all of these images in both black and white and color, just for what it's worth.
Okay. Okay, so that's Mathematica version 2 from when was that from? Version 2 from 2009. So that must have been an archaeological thing at that time. Let's see what's under pending. Oh my gosh. That is really disappointing when there's a huge amount of stuff listed under pending. That is a bad sign when there's all sorts of stuff listed under pending. Wow. Okay. State transition graphs. That I wonder what some of these things are. MW choices. I wonder whether that's multi-way systems. That is multi-way systems. Huh. Huh. That might be interesting to us now. Let's take a look. Multi-way theorems. Oh, don't tell me that's a... Okay, this is for a computer of a much smaller screen. mwtheorems.eps. Oh. Okay, that was a thing that we actually just had in the meta mathematics post. We had a modernized version of this. That's interesting to see. We might want to pick that out. MW theorems.
Okay.
Okay, what on earth is this? 1999. Something to do with sums of 3 sine waves. Yeah, I remember there's a note about that in the book of trying to look at it as a sort of toy model for the Riemann zeta function. I don't know quite why. I mean, that sort of got finished. Multi-valued logic paper. Who knows? Matthew Sudzik, also somebody I've been in touch with very recently, and was working with us again. He's also the person who's been a lecturer at our summer school I believe every single year in the 20 years that the summer school has existed, Matthew has been a lecturer, and I wonder whether I'm sort of curious what this contains. Oh my gosh, there's probably a lot of interesting stuff here.
Could some of these be computational essays?
I'm sure they could be. That one looks like it could be. I mean, a lot of these Matthew Sudzik ones probably could be because he tends to write things out in a very explicit way.
Okay.
What is this? Oh boy, this is a whole thing that has now become an industry in graph rewriting, although we kind of discovered it independently. Huh. Okay. That's an analysis of primitive recursion with SK. Don't tell me that's a combinator thing. Oh no, it is. Oh my gosh, there's nothing new in the world. Oh, I don't believe it. Okay, this would have been good to have found in connection with look at that. That's fun. This is something that should have been picked up in our study of combinators in 2020. I had no idea this was here. This is the moral of this story is organize your thoughts into things that you can remember, so to speak. I mean, I'm sure I sort of commissioned this piece. And that's the translation of combinators to primitive recursion. That's what primitive recursion to combinators. That's kind of nice. Wow, a lot of interesting stuff. SK emulate. Okay, so there's a bunch of combinator stuff there. I wonder what special relativity 4 is. No, those were pictures that I'm not sure made it into the. I don't think these made it into the book, or maybe they did a little bit, but not much. Oh, this was the horror of TM600720. This took us forever. This was a particular Turing machine, and which has incredibly complicated behavior, and we were trying to decode what it actually does. And that was an effort at that. Well, this is a lot of good material here. I wonder what. Oh, this is on. Oh, that's interesting. Those are. I think we used some of these. These are statements purely in Peano arithmetic of various known mathematical results. Let's see, combinator arithmetic part 2. This was again something that's been looked at again recently. I think this has now been, what the heck is this? That's some random thing that I invented at some point. Oh, yeah, right. Those are more straightforward numerals. Which I think we rediscovered in connection with the recent combinator work. Oh well, okay. I wonder what CB. I suspect that's a combinator related thing. Axiom ordering 2. And there's other weird stuff here, which I think, let me see what's here. I'm now curious what some of these other things are. Oh my gosh. That was an effort to deconvolve aerial photography for a particular purpose, but I don't think it's relevant to, it was not really relevant to, how fascinating. This was an effort to simulate before it was possible to do this in okay, this was a simulation of sunlight to do with sighting. Yeah, that was a different story. I'm surprised that's in this folder. It's not really, it doesn't really belong here. Amusing that it's there, but it doesn't really belong here. Okay, so there's a huge amount of material here. I wonder what that is from 2000. Invariants for cellular automata. Oh, I remember what this is. Yeah, this unfortunately didn't work out that well. That was an attempt to find certain kinds of additive invariants. What the heck is that? Oh, that's a nice piece of office art that was made by Igor Bakshi and that I have here. And this must have been the original computational way of doing that. Wow, that's nice. Yeah, making I have it right on my wall. That's a Rule 30 made out of stones. Huh, we should pick this up because that would be a nice thing. It would be a nice thing to make a demonstration out of.
Is that castories.nb?
CA stones.
Oh, stones, thanks.
Scrapbook captions. Okay, that again doesn't seem too relevant here. Old stuff. Oh no, look at all this stuff. Look at all this stuff. Look at all this. I don't know why there's so much stuff from 1999. Okay, there are animals again. The Great Mosque of Damascus, misspelled, disappointingly misspelled. Leaf shapes, leaf array, trilobites. Okay. There's a lot here. Amazon large gift. Now, the question about that is it Amazon, the book selling company, as it was at the time? I think that's Amazon, the book selling company. I was wondering whether it was going to be Amazon, the river. You never can tell. Okay, let's take a look. What else is here? Random.nb from 1998. One wonders what that is. Random networks. Okay, not too exciting. That was, I think, ended up in a page in the book. Let's see what Oyvind had here. Not too much. All right, the big real meat of all this stuff is, that was 1990. Oh, I see. Those were actual full sections there. The real meat, I think, was in these topics and topics 95, topics 96, and so on. Topics was the original collection of I don't know, if we take number theory, for example, that will have been, oh my gosh, yeeps. Okay, tons of stuff here. Tons of stuff. This is from 1993. Bunch of stuff from 1993 here. Oh my gosh. Diophantine equations, October 1993. Who knows? I think I was interested at the time in, I was interested in simple Diophantine equations whose solution sets are complicated. Hilbert's 10th problem, recurrences. I wonder what that is about. Oh, I see. This is evaluating certain kinds of recurrences, these nonlinear kinds of recurrences that I was interested in. Somebody asked about file extensions. .ma was at that time was a Mathematica file that was renamed .nb some years later. And I think we went back and replaced the .ma files with .nb files here. So, okay, so this was just one section about number theory here. And if we go back, oops. Oh, so much stuff here. I wonder what was color pictures. Cover designs, 1998. Oh, wow. This is raw PostScript graphics that had the bitmaps upside down for some mysterious reason of PostScript bug. Nice colors, though. I thought we fixed all of these. So those were just sample cellular automata. I'm curious now. Boolean functions. What did Dana have to say then? No idea what this is. Oh, that looks like it's some algebraicization of Boolean expressions. Okay, evolution is probably biological evolution. And that looks like one of those experiments that everybody does many, many times. Oh yeah, there's a version of this in the book actually, where you're taking a certain fitness function and you're doing things like randomly updating the a rule or just values to maximize that fitness function. Rather straightforward experiment. General. Huh. Ideas.89. Well, that's probably the thing we already looked at. Measurement. That's interesting. I just was studying measurement just right now. What on earth is this about? Don't tell me I already did this. We've been trying to develop a theory of measurement recently. Oh, I wanted one of these just recently. Maybe this says who wrote it. Oh, this is not ours. This is wow. Well, this should be in the function repository. A version of this should be in the function repository. And it probably was in the original thing called math source, which was a way of distributing material that predated the web.
I don't know what team that goes to, but I can take note that it should be in the function repository.
Yeah.
Okay.
But I wonder what this corners.ma. It's amusing. I mean, oh boy. Oh, this was amusing. This was a funny story. I was considering if you really want to have a book that this should be in demonstrations. This iPix.nb.
Okay.
From 1998. Let's see. Well, I think this stuff. Oh gosh, I really should remember this directory because we literally been working on that. That would have been the other topic that we would have covered in this. I mean, this looks like mostly visual perception kinds of things. Okay, this is Walsh transforms from Richard Crandall, I suspect. Oh my. There really is an awful lot of stuff here. And there's an awful lot. Okay, models. Oh my gosh. So much here. So much. Video feedback. Well, I think we never really managed to get that to completely work, although today we probably could. This would again be a good demonstration, this video feedback thing.
Okay.
If we don't already have that. The good news is that the vast majority of things I'm finding here made their way into the book, and I know where they are. It's a minority of things that are here that were just sort of lost in time somewhere in a file system far, far away, so to speak. I wonder what networks has in it. Oh boy, this is all related to pre-versions. What the heck is that? Don't tell me that is a pre-version of the thing I just wrote. It is. Well, I did it better now. That's good, at least. This is a pre-version of multi-way systems based on numbers that I just wrote recently. Oh, look at that. The complex case, which I also just wrote about recently from 1993. Oh dear. That's kind of, the good news is oh, look, those are nice. The good news is that oh, that's interesting. I didn't think of doing that now. Huh. Well, that's interesting. I didn't think of that again now. Okay, that's a reminder for myself to look at that again. That's a kind of let's make a note, multi-numerical complex. That's something to look at in connection with the multi-way systems based on numbers. Maybe I can add, I know what you add, a post note that is a pre-note that says in 1993, I also did this thing, which is relevant to what's here. Oh my gosh. Oh, these are multi-way systems. These are searches for multi-way systems. When were they from? 1997. Okay, so this must have been an early attempt to do multi-way systems. Here we go. These are the multi-way systems. And that was from 1994. And that's what we've just been looking at recently. Well, wow. I wonder what that is. I don't know why it keeps on opening behind my current thing. Oh, these are, oh, that's interesting. These are semigroups with undecidable word problems. Again, quite related to what we were recently looking at. Tiling, we've just been looking at again. What is Usenet? Well, Usenet will be things from news groups that used to be on Usenet. I wonder what, for example, tag system. I wonder what that's about. Let's see if we can get that to work here. Oh wow, that's the post tag system. Oh my, that's something we just wrote about in no, I wonder if we have this in our bibliography of tag system work. We should check that. That's something, this is what we just wrote about in let me see. This one here. This is all about this kind of tag system, and I think I probably got it an awful lot further than this 282 steps. Yeah, well, we um, got a lot further than that. It's really quite shocking here how much stuff. I wonder what graph algebra is. That seems relevant as well. Oh wow. Graph grammars. Oh no, from 1991. Wow. Okay. Well, this is what oh my gosh. There is a huge field of graph grammars, writes somebody, Victor Yodiakin, in 1991. And but it is rather too abstract and overgeneralized to be of much use, I fear. Oh, that's too weird. That's too weird. I just had email from this person this year. I have to send this back to them. That's just too weird. I've not, huh. Well, that's fun. I'm going to pull this out and send that. That is just bizarrely weird. We're now what is it, 30 years later, and but it wasn't about the same topic. I don't think, at least. Related topic. Wow. Okay, so this is notes from people back in 1991 about graph grammars. I don't know quite why. I may have just picked this off this news group because I was interested in it. Anyway, all right. Well, there's more here. There's more. It's probably going to get even more intense here in topics 95. I wonder what was in thermodynamics. Oh my gosh. Well, you can see, you get some sense here, perhaps, of what it took to put together the NKS book. In the end, it wound up of sheets of paper being printed here. I like to think that I mean, it's sort of satisfying in a way that the things that I was thinking about 35 years ago or something are still relevant and interesting, at least to me today. And oh, that's interesting. Oh no, I can't. We just were doing something with respect to Stan Ulam, and I think Ed Pegg here was just looking at these sequences again, and I'm sure he didn't remember that he'd looked at them 20 years earlier. Oh well. And look, combinators again. That's just crazy. What's that doing? Oh wow. Okay, this was looking at the history of combinators. No, this is something again. I finally, finally nailed in December of 2020. Okay. Well, anyway, this was an early attempt to do what finally got done 19 years later, and sort out the history of combinators. Oh my gosh. Well, all kinds of things here. Oh look, multi-way systems. Look at that. Lots of stuff here again on multi-way systems, universal multi-way systems. I'm not sure we've ever really nailed those down. Okay. Oh, that's actually interesting. We should look at that again now. That's relevant again. Oh my gosh. That file, I need to like copy these files because otherwise we lose track because I don't want to lose the archaeology here.
It was universal multi-way system.
Yeah, that one there.
Everything that you've told me to know, I plan on asking Julie to copy into your general box because I don't have access to whatever you're looking at right now.
Right, right. I mean, this is all archival stuff. Yeah, this universal multi-way system looks interesting. That that's something related to well, let me just see. Let's see, March. I mean, I could take that and just go, you see, I've got a recent file. It's kind of depressing at some level. I've got a recent file that's called multi-way universality. And it's actually empty right now. So I'm going to put the copy of that file right in there. And well, so at least we're 23 years later, we're looking at the same. Oh, look, another thing to Dana. Oh wow. Okay. Yeah, I mean, this thing like this group theory thing, that will have been, we finally did this correctly in the recent post about metamathematics. Let's just see whether there's anything else here that looks particularly exciting, then we should wrap up. Oh, there's just so many things here. Just crazy. Oh, this was a whole investigation that I did about sound and what makes pleasing sounds and a theory of what kinds of sequences. Yeah, this was sort of a pre-history of Wolfram tones. What do I do under Turing machines? Undecidability. Robinson arithmetic. Okay, well, this is again. Yeah, this ended up in the NKS book. Universe 98, Universe 2000, Universe 2002. I wonder what something like that is. I have no idea. What is that? So some. Oh, who knows? I don't know what that is at all. Sprinkle. Don't tell me that was the whole sprinkling technology. Oh no, you can't be serious. That's causal sets.
It looks really cool.
Well, it was from 1991, and we just redid this and other people have redone this, and there's a whole industry, which is not. I wonder whether these pictures actually made it into the NKS book. I'm not sure that they did.
I don't recognize them.
Yeah. Well, it's so this became a whole industry, and we've now got all kinds of sprinkling functions. I wonder whether the sprinkle term have been used elsewhere. I don't know. Maybe it was independently made up here. Oh dear. Well, what is that? Oh, this is more of this crazy stuff about studying vision, which only partly made it into the NKS book. What is QED numbers? Oh, that was an attempt to understand whether that must have been very late in the, oh, I see. July 27th, 2001. So that must have been finishing off some notes. This was looking at number recognition for results of Feynman diagram computations, and needless to say, one didn't find anything particularly interesting there.
I was just going to say, I found a note that mentions QED.
Yeah, and that probably had that.
It was Feynman diagrams.
Yeah, right, and it probably had those very numbers in it. Well, anyway, there's probably oh look, causal nets. Oh, that's causal graphs. That's the original ideas for causal graphs. You know, the progress of science is at some level. I mean, it's very interesting to me, at least. I don't know, maybe to nobody else, but it's interesting to me to see, like particle propagation. Oh, you know, again, it's just crazy. I just wrote something about particle propagation in. I just posted it this last week. You know, it's about on the concept of motion, which is directly related to that. Although, again, I think I got a lot further than was gotten here, but that was 1998. So I don't know what one concludes from this. I mean, I'm just curious, what is this? When it said cat data here, turns out it's actually about cats. This is it says this notebook contains computations used to create plots in this paper, encoding by binocular disparity in the cat's visual cortex. So anyway, you know, I think it is. I mean, it's sort of amazing. Well, to me, I'm not that disappointed by what I'm finding here, because in a sense, you know, a lot of these things, we finally closed them off in very recent times. And it kind of is if anything, a bit of an inspiration to finish off more projects that I've kind of, you know, that are sitting in this file system somewhere as partly started and partly, you know, and partly done and partly not yet done. I think it's the fact that one can go back 30-something years and see things which were sort of precursors of things that we're doing now, and realize that yes, we finally nailed it now, is not too bad, not too bad. And anyway, well, I think we should wrap up here. And I don't know whether people found this interesting, but it's maybe it's like showing photographs from random trips people have done. I have to say, I always find looking at those photographs interesting, but most people just find those things unutterably boring. So I don't know whether the visit down this kind of scientific memory lane is interesting to people. I think to me, as I say, it's both. You know, people might wonder, what does it actually take to produce something like the NKS book? And the answer is a very large amount of work. And one seeing, you know, 70,000 files later, we have some notion of, you know, we can see something about what work was involved. And yeah, it's I think that the real thing at some level is, you know, is it better to have sort of ideas for things one might do and then not do them, or is it better to not have the ideas at all? And I think I've certainly alternated on this topic, but I think, you know, in the story of recent times is it's time to actually finish a bunch of things for which I've had ideas in the past. For example, the physics project is a huge example of the actual finishing of something that I had long thought about, and where there are probably thousands of files here and huge amounts of work that were done on it that didn't come to fruition until that we sort of launched the project a couple of years ago now. I think for me, there are a few other big projects, not well represented actually in the NKS book, but represented in other places, that are still sort of out there waiting to be done. And I should hurry up and do them. Life's finite. It's if one's going to get them done, by the time one's waiting 30 years to do something, it's they're not a lot of 30 years that fit in an active lifespan, so to speak. So I think it's the kind of thing where one actually has to get a move on. All right. Well, I should wrap up here, and well, thanks for joining me. And now you got to go and do a bunch of new